2. I didn't realize what an immense undertaking it would be to do a video on Dr. Walford until I began looking into the immensity of the work that he did and the immensity of what I would have to cover. So this will be part 2. This looks like it may be a 3 or 4 or maybe even 5-part video series, but I'm going to start it out with a video interview with his protege, Walter Longo, and see what Walter Longo says about caloric restriction versus periodic fasting. Longo is, of course, in favor of periodic fasting. He is also the guy that he has helped create CRON. CRON is a brand of fast. It helps people to achieve a fasting mimicking diet with pre-manufactured foods, which honestly I think would be excellent for people that have difficulty cooking and understanding calories and don't know how to use fitness apps and things of that nature. But my point is, I've tried both. Caloric restriction, and I do very mild caloric restriction. I eat about maybe between 1,600 and 1,800 calories a day, but that's not ridiculous caloric restriction. Sometimes I'll occasionally eat 2,000 calories a day, but that's once a week or less that I'll have 2,000 calories, or if I'm doing heavy exercise. So I don't regularly consume over 1,800 or 1,900 calories a day. I kind of stay in that sweet spot of 1,800 calories a day. But what I found in my personal life is that caloric restriction with exercise is safer, and I've had far less side effects than with periodic fasting. But I'm going to let Dr. Longo explain, and I'm going to interject some of my thoughts into this. Now, who's interviewing him is Dr. Rhonda Patrick from Found My Fitness. I strongly encourage people subscribe to her newsletter and follow her on all social media, and also seek to watch all of her stuff. I'm going to be covering her later also when I do these videos. She is a very amazing person. She's the protege of Dr. Bruce Ames.
Calorie restriction is, let's say, 20 to 30% restriction in calories. So you're basically eating all the time, and you just happen to eat less calories. Fasting and periodic fasting.
Now we're going to go over that. There are different ways to implement calorie restriction. You are not simply eating all the time necessarily. There are, for example, there's intermittent fasting, which is every other day eating. There's time-restricted feeding, which is more or less what I do, which helps you to restrict calories. And actually, what's funny is I got the idea from Longo's book, which is just simply not eating for 12 hours, including the time that you're sleeping. So it's not like there are different ways to implement caloric restriction. It's not simply that you're eating the same as you would normally. There are different ways to implement it, but let's continue.
Are much more extreme, and we really use them to trick or manipulate the system, orchestrate a lot of genes.
Sorry. Unfortunately, we missed what he said because I interjected at the wrong time. So let's put on the transcript here too, so that you guys don't miss that.
Calories. Fasting and periodic fasting are much more extreme, and we really use them to trick or manipulate the system, orchestrate a lot of genes to get it to do things like increase protection a lot or turn on stem cells. And so you can't, a lot of these things you can't get by calorie restriction, but you can get them by these more extreme interventions. And calorie restriction also is missing the biggest component of the periodic fasting, which is not fasting itself, but it's refeeding, right? So most people think of the...
Now, what I want to point out here, the refeeding, it's not necessarily missing the refeeding. If you're practicing the every other day fasting method, which is where you're eating every other day, or the time-restricted feeding method, you are refeeding at the time that you are eating. So it's not necessarily missing that component depending on how you are practicing caloric restriction. So let's see what he has to say here.
Restriction as what's working, but it turns out, as we've shown in a number of papers, that is the refeeding that is doing most of the work, right? So for example, when we publish on regeneration, the stem cells are turned on during fasting, but it is the refeeding that causes the rebuilding of the system. And so the most important part is the refeeding. And in calorie restriction, of course, you never have that. So it's really interesting how...
As I said, that's not necessarily true. It has to do with how you are implementing the caloric restriction.
How this works, and it's a very coordinated effect based on cycles of fasting and refeeding.
So this is from the National Institute of Health. Right here you can see National Institute of Health, and it's the Institute on Aging. So what do we know about calorie restriction? Well, let's talk about different forms of calorie restriction. Okay, time-restricted feeding. Meals are consumed within a limited number of hours. This is what I do, 6 to 8 hours, okay? I consume my meals within 12 hours, but not really, because I'm obviously not eating for all 12 hours. Alternate day fasting is another means. Eating is restricted every other day, and no minimal calories can be consumed on the days in between. The 5 to 2 eating pattern. So this is what I'm explaining. There is that refeeding period. The 5 to 2 pattern would be eating is unrestricted for 5 straight days each week, followed by 2 days of restricted caloric intake. Periodic fasting, which is what Dr. Longo talked about, which is caloric intake is restricted for multiple consecutive days, such as 5 days in a row, once a month, and unrestricted on all other days. What's the evidence? More animal research has been done on calorie restriction than on fasting. In some experiments, calorie restriction is also a form of fasting because the lab animals consume all their daily allotted food within hours and go many more hours without food. In these studies, when rodents and other animals were given 10% to 40% fewer calories than usual, but provided, so 10%, that's not a whole hell of a lot less, okay? Many showed extension of lifespan and reduced rates of several diseases, especially cancers, but some studies did not show this benefit, and in some mouse strains, calorie restriction shortened lifespan rather than extending it. In nematode worms, a fasting diet increased lifespan by 40%. A study with fruit flies found that caloric restriction, but not intermittent fasting. So let's look at that again. Found that caloric restriction, but not intermittent fasting, was associated with living longer in fruit flies. One study of male mice found that lifelong alternate day fasting increased longevity, mainly by delaying cancer occurrence rather than slowing the aging processes. 2 National Institute of Aging supported studies in rhesus monkeys sought to find out whether the benefits of calorie restriction are seen in longer-lived species. In both studies, the monkeys were kept on a calorie-restricted diet, 30% fewer calories than for the monkeys in the control groups, for more than 20 years. Although there were differences between the 2 study groups, including monkey breed and type of food, both provided evidence that calorie restriction reduced the incidence of age-related conditions. Keep that in mind. Calorie restriction reduced the incidence of age-related conditions, such as cancer, heart disease, and diabetes. One study found an extension of lifespan, while the other did not. Many of the monkeys are still alive, so the full impact of the calorie restriction on maximum lifespan has yet to be determined. What's the evidence for human studies? Some study results suggest that calorie restriction may have health benefits for humans, but more research is needed. There are no data in humans on the relationship between calorie restriction and longevity. Some people have voluntarily practiced extreme degrees of calorie restriction over many years in the belief that it will extend lifespan or preserve health. Studies on these individuals have found markedly low levels of risk factors for cardiovascular disease and diabetes. The studies have also found many other physiological effects whose long-term benefits and risks are uncertain, as well as reductions in sexual interest and ability to maintain body temperature in cold environments. Okay, now this has to do, I think, more with really aggressively restricting calories. Anybody that's aggressively restricted calories, some people may have noticed that in my videos. When I've aggressively restricted calories, I've actually lost my hair due to restricting calories. I wasn't having any vitamin deficiencies or anything because I was obviously supplementing. But the thing is, when you aggressively, and that's why I no longer aggressively restrict calories, I more mildly restrict calories and engage more in physical activity. The other thing I've noticed is, of course, when you restrict calories too much, you're not going to be able to aggressively approach physical activity or even approach physical activity. It's not a possibility if you're restricting calories too low. Like when I was on a 1,500 calorie a day diet, physical activity was just very difficult for me. I didn't have the problem with inability to maintain body temperature, but my body temperature is generally like 95.7. I have a lower body temperature, but I've more or less restricted my calories since I've been an adolescent due to being overweight. So I've always practiced mild caloric restriction in some form or another, and that might be why. Okay, in this study, and I'm going to go over this study, this calorie study, 218 young and middle-aged normal weight or moderately overweight adults were randomly divided into two groups. People in the experimental group were told to follow a calorie-restricted diet for 2 years, while the other control group followed their usual diet. The study was designed to have participants in the experimental group eat 25% fewer calories than they had regularly consumed before the study. Although they did not meet this target, they reduced their daily caloric intake by 12% and maintained on average a 10% loss in body weight over 2 years. A follow-up study 2 years after the intervention ended found that the participants had sustained much of this weight loss. It's important to note that calorie restriction regimes are not starvation diets. Take note of that. Calorie restriction regimes are not starvation diets. The weight loss achieved with calorie restriction in the calorie trial resulted in body weights within the normal or overweight range compared to participants in the control group. Those in the calorie restriction group had reduced risk factors, lower blood pressure, and lower cholesterol for age-related diseases such as diabetes, heart disease, and stroke. They also showed decreases in some inflammatory factors and thyroid hormones. There is some evidence that lower levels of these measures are associated with longer lifespan and diminished risk for age-related diseases. Moreover, in the calorie-restricted individuals, no adverse effects. Now remember, at 12%, not any crazy amount, not 25%, not 30%, nothing like that, 12%. Okay, so mild caloric restriction. The calorie restriction intervention did cause slight declines in bone density, lean body mass. Now again, this can be ameliorated by supplementing with certain amino acids and minerals and things of that nature. I do not believe that they were supplemented. That's one of the problems. Supplementation is key here, and as I say that, I want to remind people I'm not a doctor, I'm not a physician, I'm not a dietitian, I'm not a nurse practitioner, not an LPN, not an RN, nothing like that. So don't take my advice. I'm not a dietitian, not a nutritionist. This video is for entertainment purposes only. What's the evidence for human fasting? Most research to date has focused on the weight loss aspect of fasting, primarily in obese people. Observational studies have been conducted in people, blah, blah, blah. For example, one observational study compared people who routinely fasted as part of a religious practice to those who did not fast. It found that those who routinely fasted were less likely to have clogged arteries or coronary artery disease. However, the study did not control for other factors. that could have affected the results, such as the kind of diet, quality of food consumed, or other nutritional supplements. How does calorie restriction or fasting work? After decades of research, scientists still don't know why calorie restriction extends lifespan and delays age-related diseases in laboratory animals. Do these results come from consuming fewer calories or eating within a certain time frame? Are the results affected by the diet's mix of nutrients? I think the diet's mix of nutrients are very important, and of course the less calories, but several studies have focused on what occurs inside the body when calorie intake is restricted. In laboratory animals, calorie restriction affects many processes that have been proposed to regulate the rate of aging. These include inflammation, sugar metabolism, maintenance of protein structures, the capacity to provide energy for cellular processes, and modifications to DNA. Another process that is affected by caloric restriction is oxidative stress, which is the production of toxic byproducts of oxygen metabolism that can damage cells and tissues. Several of these processes were similarly affected by calorie restriction in the human calorie trial. However, we do not yet know which factors are responsible for calorie restriction's effects on aging or whether other factors contribute. Research supported by the National Institute of Health, again, supported by the National Institute of Health. Everybody wants to blab about how capitalism does this and capitalism does that. That's taxpayers' money. That is socialism funding the forward momentum of basic science that will extend life. Why is that socialism doing that? Because there's no profit in it. Food for thought while I'm talking about fasting. During fasting, the body uses up glucose and glycogen that turns to energy reserves stored in fat. This stored energy is released in the form of chemicals called ketones. These chemicals help cells, especially brain cells, keep working at full capacity. Some researchers think that because ketones are a more efficient energy source than glucose, they may protect against aging-related decline in the central nervous system. That might cause dementia and other disorders. Ketones also may inhibit the development of cancer because malignant cells cannot effectively obtain energy from ketones. In addition, studies show that ketones may help protect against inflammatory diseases such as arthritis. Ketones also reduce the level of insulin in the blood, which could protect against type 2 diabetes. But too many ketones in the blood have harmful health effects. This is one of the reasons researchers want to understand more about how calorie restriction diets work before recommending them. Why is science uncertain? Despite a lot of research on calorie restriction and fasting, there are no firm conclusions about the benefits for human health. Most of the relevant studies have been conducted in laboratory and animal models from yeast, blah, blah. I don't think that the science is really that crazy. We know that people that don't overeat tend to live longer. We know that, and that's what I think really needs to be understood is from the blue zones, I think it shows that. Not overeating and eating a nutrient-dense diet, as I put in my video on how to extend lifespan, calorie restriction was not really mentioned. But what was mentioned was a nutrient-dense diet rich in fruits, vegetables, whole grains, and proteins like fish, okay? And not so much with the meat and the dairy. Okay, so that's what needs to be understood. A tremendous number of organic and chemical processes in the human body. Functioning researchers must sort out how these processes are affected. So they might not know exactly how it does it, but they do know that it does help with the biomarkers of aging and most likely does extend human lifespan. And that's what's important to understand. So I'm going to move on now. Okay, this is the calorie study. And I want to skip to the findings because we already covered a lot of this. You can read this on your own. So participants that were assessed were randomly assigned Okay, baseline 2 years of all measurements, conventional metabolic, diastolic, interpretation. 2 years of moderate caloric restriction. Remember, 12% is what they actually achieved. 12% restriction resulted in significantly reduced multiple cardiometabolic risk factors in young, non-obese adults. These findings suggest the potential for substantial advantage for cardiovascular health of practicing moderate, remember 12%, calorie restriction in young and middle-aged healthy individuals, and they offer promise for pronounced long-term population health benefits. And again, this was funded by the National Institute on Aging and National Institute of Diabetes and Digestive and Kidney Diseases, National Institutes of Health. Okay, so what this is, again, this is socialism moving science for the public good forward. Why? Again, because there's no profit in this basic science. However, I guarantee you, once there is, somebody's going to be cashing in on it.
In nutritional research on aging. The third phase, which is the one I initiated in this general area, was the effect of caloric restriction on the physiology of the body, on the immune system, on liver biochemistry, on gene expression, and matters of that nature. Most of my work has been on the immune system, and we've shown that calorie restriction largely prevents or delays the otherwise age-related decline in the immune response capacity, in the ability of the body to fight off infections and so forth.
So caloric restriction helps to aid in reducing immunosenescence.
Final phase, or the current phase of this general area of nutritional work, is the search for mechanisms. What is the basic mechanism whereby merely restricting calories has these global effects on the body, influencing aging, lifespan, disease, development, and all of these physiologic parameters?
This is with rodents. Does that relate to human beings in any way?
Yes, it relates with a high order of probability to human beings. The justification for animal research, in fact, is its relation to human beings eventually. But caloric restriction has been explored and works in all the way across the animal kingdom so far, from one-celled organisms up through snails, flies, worms, and so forth, and higher up, spiders, through mice, rats, and initial results in monkeys being conducted at the National Institute on Aging seem to show retarded aging. So it is...
We may want to back up on that.
Yeah. So, okay, right. How does this relate to human beings?
With a high order of probability, the work in animals is directly applicable to humans. This is really the basic assumption in animal research anyway, in all kinds of animal research. However, the caloric restriction specifically has been shown to have these effects, extending lifespan in one-celled organisms, in worms, flies, mollusk, fish, mice, rats, and in ongoing work at the National Institute of Aging.
What people need to understand is a lot of the genes that are present in the human being are also present in these model organisms. So that should be kept in mind. So if there is a genetic reason that this is happening, it's probably going to happen in people as it does in organisms that share many of our genes.
Very likely in monkeys. So it seems to be what we call phylogenetically independent. It works all the way across the animal kingdom. And so it would be enormously surprising if it didn't work in humans.
Right. To define it, because one would think that if you were on, say, people who have low, at the moment, through no fault of their own, say people in Ethiopia and so forth, in Africa, who have very, very little nutrition.
I always like how they try to compare people that are malnourished to people that are on a calorie-restricted diet with optimal nutrition. Now let's see him explain that, because that should be funny.
Don't seem to live very long, basically. What's the fine difference between having a restricted diet and having a starvation diet?
The reason people in, say, underdeveloped countries where there's a lot of starvation and very low-calorie diets don't enjoy this effect is because what they're eating is nutritionally inadequate. Their diets are lacking in essential vitamins and minerals and so forth. And so that, of course, doesn't extend but shortens life. The low-calorie effect has to be balanced with fully adequate nutrition for the essential nutrients, essential amino acids, essential vitamins, minerals, fatty acids, and
Note that he explained the essential amino acids. That's very important because a lot of people are talking about protein restriction. I jumped on that bandwagon and quickly jumped off when my health started not doing so well under the starch solution. So keep that in mind. That's why one of the reasons I supplement with branched chain amino acids today is because of that. I found out that I needed those amino acids.
so forth. So it's a very select kind of regime, and you can't think about people in starving countries. No, that's not applicable.
Right. Do you think it's possible to, and now, if somebody wanted to say, well, fine, what's happening in research appears to be working, it's worth a chance, I'm going to start taking this diet myself. What would they have to eat to do it? I mean, would it be a matter of just of dieting for the rest of their life, or is it something much more specific?
Well, if they have to lower their calorie intake so that they gradually lose weight over about a 4 or 5 year period. It has to be gradual to be effective when beginning in adulthood. Gradually lose weight over a 4 or 5 year period until they're 10 to 25% below their so-called set point, where the set point is what you normally weigh if you kind of eat as much as you want. Below the set point then, and that will have the effect. And what you actually eat is, well, I've written a couple of books, diet books on that, but basically it's food that's high in nutrient value, and it has to be...
I do strongly recommend his books, particularly Maximum Lifespan and the 120-Year Diet. They're the two books I own. I do plan on buying more of his books. I highly recommend his writings to people.
Together in a way that on each day, in the 1,500 to 2,000 calorie allotment that seems to work, let's say, for you to lose weight.
Now notice, 1,500 to 2,000 calories. That's not really that restrictive, okay? That's not very restrictive at all. That's kind of what most people probably should be eating anyway.
Gradually, you reach 100% of the recommended daily allowances for all the essential nutrients. But to name specific foods, it's generally wholesome foods like a lot of vegetables, grains, not highly polished grains, but unhulled rice, for example, and things like that, and fish, vegetables, grains, fruits.
Would you take a vitamin supplement with it? Or?
Well, I think it's fine to take a moderate amount of vitamin supplements.
I think that in his books, he talks about the importance of supplementation. However, I don't think that he, because of his competition with Dirk Pearson and Sandy Shaw, he did not talk about the importance of supplementation enough. I believe supplementation is extremely, extremely important for this type of diet to work at all.
Supplements too, the recommended daily amounts of the vitamin supplements. But I think it's wrong to think that you can eat a kind of a average American or...
And he's right. You can't supplement your way out of a bad diet, and you can't exercise your way out of a bad diet either. And you also can't eat your way out of not exercising.
European diet, but just eat less of it and then supplement it. That's kind of a junk food diet with added vitamins, and I don't think that will work. It might work theoretically if we knew totally everything there is to know about nutrition, but when you get into that, you begin missing elements that we don't know very much about yet. So I think it's dangerous to think about doing.
He means things like phytonutrients and essential fats and things that we didn't, especially at that time, we didn't know very much about. They're learning more now. And that's why vitamin P is talked about by Dr. Wallach and Dr. Ames. Very important stuff. These little-known substances, coenzymes like coenzyme Q10 and alpha-lipoic acid, things of that nature.
It that way.
Right. Prediction slightly into the future, if it's proved categorically that this does work with humans, do you think we could educate mankind on...
Yeah, little voice. Stand by.
Does it sound okay?
Mm-hmm.
Right.
And speed.
Right. Do you think we could educate people. I mean, food plays an awful lot in our society and our culture. Do you think we could educate people to eat a lower diet, a low diet?
Food plays a big part in the culture, but it is possible to educate people to eat a lower diet. A lot of people are following what I have said in the books I've written and are eating in this way. I don't think everybody will. People are being educated, for example, now to eat less fat, to eat more fibers and things of that nature, and to a certain extent they do. The incidence of heart disease is going down in the United States anyway, because people are on the whole conscious of not overindulging in fats and cholesterol and so forth.
Would the diet become boring, do you think? Or is there a way, I mean, well, what I should say, start again, is do you take the diet, presumably you do yourself?
Yes, I've been on the a low-calorie diet for 4 or 5 years. No, it's not boring. You have to add spices and cook foods the way you like them. Is a fair.
I always find it funny that people are concerned that food is boring or that food will become boring. A lot of rich ethnic foods that people spend good money for can be made both vegan and in a calorie restricted manner, a low calorie manner. It's amazing how many people think that, low calorie food or vegan food or vegetarian food is somehow boring. It's not. A lot of the food of the world is low calorie and vegetarian.
Out of beans, vegetables, grains, and so forth, and they can be cooked in a quite an appetizing way. For example, the Indian diet is almost purely vegetarian. Whether you like it or not, it's variable and spicy and so forth. That's not a problem. Vegetarians generally have quite a good diet. The one I'm talking about is not necessarily a vegetarian diet, but one can prepare beans and rice and vegetables in a wide variety of ways, and it's not boring.
I would normally think of people who eat less food as having not the same sort of energy that someone who eats a full diet. Is this true or not?
No, that's not true. People on a low-calorie diet, if it's nutrient sufficient, have more energy than people who are overeating. One can see that in various, even clinical conditions. For example,
I don't find that to be 100% accurate. I did find that maybe 1,600 to 2,000 calories, but when I was on 1,500 calories a day, I did not have more energy. But keeping my calories to about 1,800 calories a day, I guess I do have sufficient energy, I would say that. But, yeah, I aggressively restricted calories, no. So I think that maybe he's saying 1,500 to 2,000 calories for the average person. I probably had my calories a little too lower than they should have been.
Nutrient sufficient have more energy than people who are overeating. One can see that in various, even clinical conditions. For example, in anorexia nervosa, which is eventually a fatal disease if people stay on it. But in the early stages of that, anorexics usually eat a very good diet qualitatively. They'll eat, say, 1 egg a day, something like that, which is quite nutritious, but still at a starvation level. But in the early stages, they're known to have a lot more energy than people eating a regular diet. They also have an increased immune response capacity. So you begin to see the effect of calorie restriction in the early stages of anorexia. Then it goes away because they starve to death. Low calorie, your body adjusts to it, and you have an increased metabolic efficiency. Metabolic efficiency, if everything is perfect in the body, can be up to 50%. That is 50% of your fuel you can use adequately. The rest is burned off as wasted heat or in so-called futile cycles. On a normal full diet, you only reach 35% efficiency. On a low-calorie diet, you reach about 50%. And this is converted into more energy and less wasted material floating around.
Why do you, does anyone...
Now, what's interesting about that is the less wasted material floating around, less extracellular junk and gunk.
Have you postulated why?
Remember, extracellular junk and gunk is one of the things that causes aging.
this has the effect of diet and longevity and the immune system.
The mechanism whereby calorie restriction has these effects is kind of a big question now for not only for me but other people working in this area. Well, it delays the age-related decline in the immune system. That's one possibility as to mechanisms. There is, for example, an immunologic theory of aging, which that would fit into. It also upregulates the level of so-called free radical scavengers in the body. Those are chemical.
It increases the amount of endogenous antioxidants, things like glutathione. Okay, everybody blabs about glutathione. Following a calorically restricted diet will increase your glutathione.
Produced by the body to neutralize the effects of so-called free radicals, which are injurious, hyperactive oxygen elements generated during the course of normal metabolism. Calorie restrictions upregulates the defense against these. It also increases the level of DNA repair in your body. And there is a DNA repair theory of aging. So it does about all of these things that fit in with anybody's theory of aging. It's therefore kind of difficult to select which is the primary effect, if there is a primary effect. So there are a lot of possible mechanisms. We don't know exactly which.
Should you also take then to sort of cover yourself, say, double insure yourself, would it be sensible to take this diet plus take a free radical, an antioxidant regime of vitamins and minerals and so forth?
Well, in regard to antioxidant regimes, I'm not against them. I think there's a lot to be said for some antioxidants, for example, vitamin E, vitamin C, and selenium. However, there isn't any evidence in the medical literature that antioxidants by themselves will really retard the rate of aging and extend lifespan. So while the free radical theory of aging and the taking...
Now, there is some evidence that has been found, and I'll show that in later videos, about vitamin C and extension of lifespan, but also what you have to take into consideration, vitamins, especially antioxidant vitamins, and as we know from the triage theory of aging and disease, which I'll get into with Dr. Bruce Ames, not only antioxidant vitamins, but vitamins and minerals in general are necessary to retard the effects of aging. But we know this now. And certain people like orthomolecular physicians and Dr. Joel Wallach, they knew that. But Dr. Walford is going in a different direction here. This is one of the problems with the scientists, is they sometimes have pet theories and they do not entertain the theories of others, but it's very interesting. So we're going to let him continue speaking here.
Antioxidants sounds very plausible. There isn't any hard experimental evidence that it really works out. Whereas for caloric restriction, there's abundant evidence in the animal literature for years that it retards aging.
You take it, could I ask how old you are, sir?
67.
Right. I must say you don't look it. Do you anticipate, I mean, it's obviously difficult, but at what point in your life, if you started this regime now, say at 40, where would if a bus didn't hit you, where would your natural lifespan extend to? What age would you guess?
Well, one very roughly, and this is very rough as I say, at any age that you start, if you do calorie restriction very rigorously, it will retard your rate of aging by about 50% from that time on. So let us say you started at age 40 and that your genetic potential were to live, if you were eating normally, were to live to be 80. So if you retard your rate of aging by half, then instead of having another 40 years, you'd have another 80 years. So you'd live to be 120 if you start at 40.
And would that 120, would the last part of your life, say from 70 onwards, be as an old person, or would you be younger and look younger, feel younger?
You'd be, when you were 70, you'd be about 50 in terms of what you looked like and in your general function, your intellectual capacity, your physical prowess, the wrinkling of your skin, the graying of your hair. When you were, let's say 100 or 110, you would look about what you would have looked when you were 75 or 76. So it stretches out whatever the period is, but it doesn't just add old years onto old years. So the picture of getting a lot of chronologically old and decrepit people running around on a caloric-restricted diet is not correct. It will produce chronologically old but functionally much younger people.
If you started this, was there an optimum age? Now, someone is looking at this program in England and they're 20 and they say, well, crikey, if I'm 20, what sort of age could I possibly live to? Is there an optimum age that one should start this?
The optimum age is the younger the better, but not until one has achieved full growth. If you do caloric restriction starting in very young animals, they live longer than any other animals, but they're smaller. So I don't think that's a good choice to inflict on.
So it looks like Dr. Walford would be against giving hormone blockers to healthy children, because what do you know, if you give hormone blockers, if you're retarding growth, what do you know, it causes issues. What do you know, he's against that. Going back in time to find that out.
Children, people should wait till they have their full growth if they want to do this and then start on it.
So if you did it if we took that person who was going to die at 80 and he started at 20, he could presumably then live to 140 or even longer.
Yes, that's true. If you start it, if it follows along, and you have to do a pretty rigorous calorie restriction regime to really come up to the maximum lifespans obtained by calorically restricted animals. But
Now, when I get into talking about Dr. Kenneth Cooper and the physical exercise, fitness, and all that, you'll see that you don't really need that aggressive of calorie restriction if you're optimizing, if you're dialing in your diet and dialing in your fitness, as well as mild caloric restriction.
degree of restriction will extend life a certain extent. For example, animals restricted 10% will live longer than animals that are fully fed. 20% restriction gives animals living longer than 10%. 40% longer than 20%. So the lifespan increases the more the restriction, down to about 50%. At that level and below that, then animals start dying off, because there you get into the point of actual caloric starvation. So if somebody starts at 20 and they really do it tremendously rigorously, say 40% restriction or so forth, then they could live out to be 140, 160, according to the animal data. Probably people will not want to do it that heavily, but that's a personal choice.
Say you did, and you suddenly you went to a party and you decided to have some apple pie and ice cream, or go out with friends for a big meal one night. Would that dramatically affect it, or can you have the odd occasions where you do break the diet?
It's a long-term effect, and you can break the diet once a week or something, as long as you're, on the whole, your weight is kept below your set point.
I'm someone very much against cheat days. I see them as a slippery slope, so I'm not big in maybe eating more calories, but I would not start eating bad food such as cake, ice cream, etc., candy, what have you. I would stick to the the highly nutritious foods.
And does animal fat come into it or not?
Well,
Should we now, I mean, the things that we've been told not to eat, milk, butter and fatty meat, etc., does that still apply to your restricted diet?
it's been found that calorie restriction, its effect is only dependent, or largely dependent, on the calorie content, independent of whether you have high protein or high fat or whatever kind of diet. As long as you have all the essential nutrients, it's the calorie effect that is prominent. Now, as far as the kinds of fats you eat, that's sort of a separate issue. I think that it's better not to eat too many animal fats. Also, fat on the whole are empty calories, so if you eat too many fats, you're not able to get full nutrition. But it's okay to eat animal fats and milk fats as long as you don't overdo it.
Right. Let's assume then that people do listen to what you're saying and they start to restrict their diet. How would society in the future be able to cope with I'm not saying an ill, but a healthy, aged population.
The long-living society will be a different society than the one today, and it'll produce a lot of kind of social revolution in many ways. First of all, let's think about overpopulation, okay? Adding people on.
Overpopulation is more or less a myth. What we have is we have natural resource issues due to the fact that greed has caused certain people to have far much more natural resources than others. With the technology we have today, with things like desalination, advances in agriculture, advances in food processing, all these things, there should be no issues with overpopulation, not to mention with advances in building, 3D printing, how we can build new housing, etc. I consider that a myth, but let's let him continue, and then I'm going to cut this video a little short and then continue with the next video.
Kind of with longer lifespans will not in the long run have much impact on the population pressure. One can think of that in this way. If you started about 10,000 BC, there were, I think, 2 to 3 million people on Earth, and now it's going up to about 5 to 7 billion due to the over-procreation effect. If you took the same initial several million people, 10,000 BC, and optimized the longevity problem and kept the birth problem in better perspective, let's say that starting with 1 or 2 million people, everybody lived forever. Nobody died from disease or aging or anything. They were still there. Everybody had one child. Every couple had 2 children, but that was all. So how many people would you have today? About 400 million. That gives a linear increase, whereas the overbirthing gives an exponential increase. So it's the over-procreation that is the real problem.
I'm going to cut this video here. I wouldn't call it over-procreation. I'll get into that in later videos that don't have to do with life extension, but I'm going to continue, of course, with, it looks like probably 5 or 6 of these videos to cover the depth and breadth of Dr. Wallach's work. So let me continue this later.